Today we're going to be learning about the domain and range of exponential functions and their graphs. The two graphs given represent a growth model and a decay model. The growth model is indicated by the green graph and the equation y equals 2 raised to the x power. The decay model is represented by the purple graph and the equation y equals 1/2 raised to the x power. Both of these graphs have one thing in common, and that one thing is called a horizontal asymptote. The horizontal asymptote of an exponential function is a horizontal line that the graph will approach but never touch. In this particular graph, the horizontal asymptote for both the decay model and the growth model is y equals 0. This horizontal asymptote indicates what the range will be also. Let's look at our first example. What is the domain of this exponential function? The domain is any x value that the graph or the function may take on. As we look to the left, the graph is going to continue to go to negative infinity, and as we look to the right, the graph is going up, but the arrow indicates that it could continue to go to positive infinity as well. Therefore, the domain of this exponential function is going to be all real numbers. One key thing to remember is that the domain of all exponential functions will be all real numbers. Next example. What is the range of this exponential function? The range of an exponential function is found by first locating the horizontal asymptote. The graph is the purple curve. The horizontal asymptote is the green dashed line. That dashed line crosses the y-axis at y equals 0. Therefore, the horizontal asymptote is y equals 0. And the range is going to be any value that is above this horizontal line or greater than this horizontal line. Therefore, the range of this particular function is going to be y such that y is greater than 0. Another key thing to remember is in order to determine whether your range should be greater than or less than, you locate the horizontal asymptote first, and then you look at the graph. If the graph is above the dashed line, then it's going to be greater than. You're going to use the greater than symbol. And if the graph is below the dashed line, you're going to use a less than symbol. Next example. What is the range of this exponential function? We first locate the horizontal asymptote, which happens to be y equals -1. Since the graph is now above that line, we know that we should choose a y value that is greater than -1. We're only going to use greater than -1. We never use greater than or equal to when we're trying to identify what the range is of any exponential function. Next example. We locate the horizontal asymptote first, which happens to be y equals -1. Then we look at the exponential function, and this exponential function happens to be below the horizontal asymptote this time. Because it's below the horizontal asymptote, that would indicate that we're going to use a less than symbol this time. Just remember that this problem asks for both the domain and the range. And we know that the domain should be all real numbers, and the range in this case is going to be less than -1. Y such that y is less than -1, which is the answer found on the right. Next example, we first locate the y horizontal asymptote first, which is y equals 6. Then we look at the graph and we determine is the graph above the horizontal asymptote or below. Since we recognize that the graph is above the horizontal asymptote, that kind of indicates to us that we should use a greater than symbol. And just remember that the domain is going to always be all real numbers. In this case, the correct answer is going to be the domain is all real numbers and the range is y such that y is greater than 6, which will be the first answer choice. Last example, the horizontal asymptote is y equals -9, the graph is below this horizontal line, which lets us know that we're going to use a less than symbol for this problem. And our answer ends up being the answer here indicated on the right. The domain is all real numbers, and the range is y such that y is less than -9. The next thing that we're going to go over today is the exponential equation using transformations of a, h, and k. This is going to help you with IXL less than x4, x dot 4. The exponential equation using the transformations a, h, and k are as follows. The k value is going to represent the horizontal asymptote of the exponential function, and it also indicates the value of the range. The a value lets us know what inequality sign to use for our range. When a is positive, the range is going to be greater than the k value, and when a is negative, the range is going to be less than the k value. So the a value helps us identify whether we're going to use a greater than symbol or a less than symbol when indicating the range. The b value, it represents a growth factor if b is greater than 1 and a decay factor if b is a fraction or a decimal between 0 and 1. And finally, the h value. The h value in transformation form represents a shift left whenever you see b raised to the x plus h power, or a horizontal shift right when you see b raised to the x minus h power. We're going to move to example 1. What is the domain of this exponential function? We learned in previous examples that the domain of any exponential graph or function will always be all real numbers. Next example, what is the range of this exponential function? So what I did was I put up the transformation of the exponential function, and what we're going to do in order to find the range is find out what our k value is. The k value represents the horizontal asymptote and indicates the range. That is what we're looking for, the range. Therefore, we're looking to find out what the k value is in this function y equals 6 to the x power. There's no number in the back behind 6 to the x power. Therefore, I know that the k value should be 0. And then the a value of the exponential function, which is the value in front of 6, indicates whether our range should be greater than the k value or less than the k value. Since my a value happens to be 1 and positive, I know that I should choose y such that y is greater than 0. So to recap, you're looking for your k value, which happens to be 0. And then you're looking at the value in front of your base, which is b, and it happens to be 1. Since it's positive 1, that indicates that we're going to use a greater than 0 for our range. Next example, what are the domain and range of this exponential function? We discussed earlier that the domain of exponential graphs and functions will always be all real numbers. Therefore, we know that our answer choice is either going to be answer choice number 1 or answer choice number 3. Next, we're going to look for what our k value is in this exponential function, and we find out that there's no value in the back here that represents k. So that value is understood to be 1. Then we look for our a value. The value in front of 9 is understood to be a positive 1 also. And because it's positive, that indicates that I should use a greater than symbol. So my answer comes out to be the domain is all real numbers, and my range is y such that y is greater than 0. Next example gets a little more complicated. In this example, we're identifying what the domain and range is, and we already know that the domain should always be all real numbers. So the next thing I need to do is identify my k value. My k value is going to represent the horizontal asymptote. Along with it, it helps me identify what my range is. The a value in this one is the number in front of your base raised to the power. My base raised to the power is 9 raised to the x minus 1, and that number in front of 9 is negative 4. Therefore, my a value is negative, which lets me know I should use y is less than k. Since I know my k value is negative 8, I know that my range should be y is less than negative 8, which is my third answer choice here. The domain is all real numbers. The range is y such that y is less than negative 8. This is the last example that we're going to go over today. This example asks what are the domain and range. Well, you already know that the domain should be all real numbers because in exponential functions, that's what our domain is going to be, always. Next, we're trying to identify our range, and our range is the number in the back, which is our k value. The k value indicates the horizontal asymptote and helps us identify the range. The a value is the number in front of b, which helps us identify whether we're going to use a less than or greater than symbol. Since the a value is a fraction and it is positive, we're still going to use a greater than symbol. Therefore, my answer is going to be the domain is all real numbers and the range is y such that y is greater than negative 2. This is the end of this presentation, which means you should be able to successfully complete X3 and X4 with 100%. Mastery score.